Good morning, everyone. Welcome to physics class. As you all know, well, I'm not here, but I just recorded this little thing for you. So today we're going to be dealing with levers. Our objectives are going to be, number one, determine the mechanical advantage of a lever. You're going to be dealing with that by yourselves at the end of this video when you are set to work on the section review. And number two, we're going to recognize the three different kinds of lever system. In order for us to do that, we're going to watch the following video.
Good morning, everyone. Today, well, as you know, I wasn't able to be with you at this moment. I'm, in Tegucigalpa. And, well, but, however, I prepared this little video for you. As you can see, we're here at the school's workshop, well, at the ministry workshop, and we're going to be dealing with levers, okay? Remember, levers are simple machines, and that is the topic of today. So, come on, follow me. Levers are one of the most versatile simple machines, and today we're going to discuss the three types. So, what we have in here is, well, we have a bar, we have a fulcrum, and we have a weight, okay? So for the first class lever, in the first class lever, we're going to have this. Here we have the fulcrum. This is the resistance, the weight I'm going to lift. And in here, I'm going to apply my effort. Now notice the direction of my effort. When I do this, I make an effort downward, and my resistance goes upward. Now, the distance from where I am inputting my force to the fulcrum, we're going to call it effort arm. And the distance from the fulcrum to my weight is going to be called the resistance arm. Now, there's another way of doing this first class lever. I'm going to move the fulcrum closer. And I'm going to do the exact same thing. There you go. Okay? Now notice that my effort arm is shorter now than my resistance arm, therefore I have to make a greater effort. Now for the second type of lever, it's a lot more simple. In the second class lever, this is what you do. My effort goes upward, and the fulcrum is right there. Let me show you where the fulcrum is. The fulcrum is right here. This is the fulcrum. Here we have the resistance, and here we have my effort. The distance from the fulcrum to where I do my effort will be my effort arm. In this case, is going to be the length of the bar. The resistance arm is going to be the distance from the fulcrum to where my weight is acting. Okay? That's for the second class lever. Now for the third class lever, the third class lever is a bit, like useless maybe, but it still exists. On the third class lever, in one end I have my pivot point. In the other end, I have my resistance. So where am I going to exert my effort? Right here in the middle. So I make my effort, and I lift up the table like this. Okay, notice that this is the pivot point, that is the resistance, and here is my effort. Now, the distance from the fulcrum to where I have my effort is my effort arm. The distance from the pivot point to the resistance is going to be my resistance arm. Okay? So now I'm going to be explaining this in more detail using Amigo Studio.
A first class lever is one that consists on a bar. So here we have a bar. This bar has a fulcrum. I'm going to use this to make the fulcrum. And at one of the ends of this fulcrum, we're going to have the effort force. And on the other end, we're going to have the resistance force. For example, if we have a load over here on this end, we apply a force in this direction to make this object move in this direction. Now, if this is the effort force, and this is the resistance force, the effort arm is going to be the distance from the pivot point or the fulcrum to the effort force. The resistance arm is going to be the distance from the resistance force to the fulcrum. Now the fulcrum can move in different positions. For example, the fulcrum can be right here, and in that case our arms are going to actually be different. There's going to be the effort arm, and this is going to be our resistance arm. Okay, if the fulcrum moves in this direction, closer to the effort force, then of course our effort and resistance arms are also going to change. We're going to have our effort arm right here, and the rest is going to be our resistance arm. So that is with first class levers. In the case of a second class lever, we also as well have a beam, a straight beam. The fulcrum in this case is going to be at one of the ends. We can have the fulcrum right here. Let me just move it a little bit and move the fulcrum right here. Our load, in this case our load is a circle, so we're going to put the load right here in the middle, and we're going to have an effort taking place at the other end. Right here, our effort goes in this direction, but our resistance goes in this direction. So if this is our effort arm and this is our resistance arm, resistance force, this is going to be our resistance arm, and this is going to be our effort arm. Notice that the effort arm and the resistance arms always begin from the pivot point. And I also want you to notice that since the effort arm is always greater than the resistance arm, the theoretical mechanical advantage for second class levers is always going to be greater than 1. So this is for second class. For third class levers, we're going to make the beam again. We have a beam. In this case, the effort force is going to be between the fulcrum and the resistance force. So we'll try to represent that. So we have our weight, which is going to be right here. We have our fulcrum, which is right here. Try to move it a little bit. Here's a fulcrum. Here's our resistance, and the effort is right here. So we'll try to represent that using an arrow. Here we have our resistance force. Here we have our effort force. And of course, there we have the fulcrum. If that's true, if we have our resistance arm over here, here we have our effort force. Now I want you to notice that this is the resistance arm, and this over here is the effort arm. I want you to note that the resistance arm is always greater than the effort arm. So for third class levers, the theoretical mechanical advantage is always going to be less than 1. So that is with third class levers.